Okay, so let's take a look at our example 4. And example 4 also gives you some kind of graph that appears to be nonlinear if you look at the entirety of the f function. So y is equal to f of x. It goes in and it comes down here and it goes up and it comes down like that. All right. So the question is, for what value of s is the value of f of x at its minimum? So let's take a few look at a few things. If you look at this, when you say minimum, that we are talking of the lowest point. So minimum generally means, let's go back and change our pencil color again here. So minimum, you just look at the lowest point, right? And of course the maximum will be the high point, right? So here for this particular graph, your highest point on this function will be this here, and then your lowest point will be this point here. Now, the first thing you want to do to be able to establish these points is to actually, number one, identify where your origin is and also identify the scaling. So if you look here, this point here is 1, and this also, it appears our origin is at this point right here. Our origin is right here. So this is 1 unit and also 1 unit up. So both x and y are 1 unit each. So what we're going to do is now let's find the minimum. We know the minimum point occurs at this point, which is 1. So that means it go negative. It's actually setting minimum is actually -2. So f of x is equal to -2 is the minimum point. Then the question is, they are looking for the x value that they give you -2. And what point is that? So this is 0, goes 1, 2, 3. It appears when x is equal to -3, we get that. So f of -3 will be the one that will give a -2. So obviously your answer here will be the choice B. You can see that.